Alright, let's solve problem 121. Best time to buy and sell stock. So you are given an array of prices, where price I is the price of a given stock on the ith day, okay? You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the max profit you can achieve from this transaction, and if you cannot achieve any profit, return 0. So let's just iterate through the prices example here. So to do that, I'm just going to give myself a nice graph, and I can do 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6, 7. So this is the price, and this is the time. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 3, 4, 5, 6, 7. At time is equal to 0, we have a price of 7. At time is 1, we have a price of 1. At time is 2, we have a price of 5. Then we have a price of 3. Then we have a price of 6. And then we have a price of 4. So our graph is going to look something like this. And what's particular about buying and selling stock? To make a profit, we need to sell at a low and buy at a high, for example. And we can make multiple of these transactions. So the way the problem is solved for this example is we buy here and sell here. So we make a profit of 5 minus, or rather, how much do we make for this one? 5 minus 1, right? So 5 minus 1 here. Wait, a single day to buy, or sorry, I didn't read the question. So we have to just buy and sell at one moment in time. So we can't just, buy, sell, we can only just do like buy and then sell. Only one buy, one sell day. Okay, so this becomes not too bad, right? We want to buy at the minimum most value. We want to buy at the highest most value. Now, obviously, the highest most value has to come after the leftmost point. So how do we do that? Well, we're just going to use 2 pointers. The left pointer is going to point at the start, and the right pointer is going to point at a index right after it. If the right index is less than the the element at the right index is less than the element at the left index, we're just going to set the left index, the left pointer, to be the right where the right index once was, and then increment the right by 1. Now, while this the element at the right pointer is greater than the element at the left counter, we can keep going because we're going to always keep making a profit. And as we go along, we're going to store what is the actual max val for the right pointer as we traverse. So right now, max val is just -1. So we're here. 5 is greater than 1. So the max val is now 5. Now we move the right by 1. Right is still greater than left, but now we've hit a value of 3. The max between 5 and 3 is still 5, so the max val is still 5. Then we can move again to here, and what we can see here is that the max val is now 6. 6 is greater than 5, so our max val is going to be 6. But what we can see is that we don't really have to store the max val. Along every incrementation, we can just calculate the profit. The profit is just the current right minus the current left, and then we just have a max, global value that then just takes the max of the current max val with the current profit as right is iterating along. So here it's now going to be, so originally here the profit is 5 minus 1. Then it became 3 minus 1, right? Then it became 6 minus 1. And then it became 4 minus 1. The max of all of this is 5, and we're going to store it incrementally. So first at 0, the max between these two is 4. The max between these two is still 4. The max between these two is 5. The max between these two is still 5. So output 5 as we see in the example. And if for some reason, for example, it dips suddenly below, right? So right gets to here, right is now less than left, the value at right. So put the left pointer where the right pointer is and move right by 1. And that's the whole algorithm, so we can program this up in Python. All right, so as we said, we're going to need a left and right pointer. They're going to be 0 and 1. And let's call n to be the length of prices. If n is equal to 1, well, obviously, there's nothing we can do here. So just put it like this. So while right is less than n, we're going to have profit to be 0, because I don't even know if we need this base case, but let's just keep it for now. Profit to be 0. So what are we going to do? So while, right, while the prices at R is less than or equal to the prices, or rather less than the prices at L, then L is equal to R and R plus equal to 1, right? Because we want to buy at a minimum value. So while L is less than, so right is less than N, we have this. So once we go past this while loop, we have spotted a min. We have bought at a min. So now we just need to perform the buy operations. So while R is less than N again, and the prices at R is greater than or equal to the prices at L, then we can say that the profit is equal to the max of the profit with the prices at R minus the prices at L, and R plus equal to 1. And with that, that's the whole algorithm. So we can just return profit at the end. And we don't really need this, right? Because this is going to account for the whole thing. Because 0 is less than 1, well, we're not going to get anywhere here. So this should work. We should run it and see what happens. And it accepts, so let's submit. And there we go, that's the solution.